It is a next line. It is a point at which it is a point at which entire mass of large body entire mass of large body it is a point at which entire mass of large body can be assumed to be concentrated can be assumed to be concentrated can be assumed to be concentrated and if external force is applied on it and if external force is applied on it, it will have same translational motion it will have same translational motion it will have same translational motion as that the large body has. External force is applied on it, it will have same translational motion as that the large body has as that the large body has. Next line. It can be real or imaginary point. It can be real or imaginary point. Hmm? Everyone, please see na. So you understood why we are taking this center of mass, why we are studying this concept. Let's say I am taking any example. Na? So there is a one truck, yes, or any bigger shape rock or anything. If someone is applying some force on it and we need to calculate acceleration velocity, so how I will do here? Let's say that much is the rock, that much is the rock, yes. So you will say, let's say, sir, here you are applying force. So you are a little bit confused. Na? It will rotate or do translational motion, yes. So what we will do now? First, we will calculate its center of mass. Calculation of center of mass means we will try to locate its center of mass. Let's say I am saying that its center of mass is here. Let's say I am saying here its center of mass. Means now what you will do, you will just replace all the body and you will take only this as a point mass m, and now you are applying force. Now you can calculate F is equals to ma from here to here. What is the displacement? Everything you can calculate like this. Yes. So to minimize the thing as a larger mass, to minimize this mass. Yes, you're getting this thing? Okay. So remember this thing, center of mass is a position. Yes, every time just remember center of mass is a position where we can assume whole mass of a body to be concentrated at one point. Next is mass moment. Mass moment. Everyone, mass moment. It is this. Sir, m r vector. What is mass moment? M r vector. Yes. What is m r vector? This is x axis. This is y axis. Everyone, please see. So let's say we have this point mass m1. Yes. And remember this mass movement, if I am writing mass movement, so let's say this x coordinate, y coordinate, this is m1 mass, this is origin. So I want to write the mass movement of this. So how I will write now? So m1 into r vector. R vector means from here. Then I say let's say r1 vector. So here m1 r1 vector is the mass movement. Getting or not? Everyone? Wait. So sir, it means it depends upon the position. Na? If you are writing from position this origin, so you will write m into r1 vector. Yes. Let's say m2 mass is this. How you will write mass moment? It is denoted by let's say capital M. Huh? This is capital M. Capital M. So how you will write this? Mass moment I want to write this mass m2 multiply by the position vector. So r2 vector. Okay, sir. Everyone, please see, na, please see. Let's say I am saying this is a r3 vector. Hmm? Everyone, what I am saying? It is a r3 vector. Now what I am saying, na? Now I am here. Observer is here. Observer is here, or I am writing in this way. write the mass moment of m1 mass, yes, m1 mass with respect to m2 mass. Means till now we are writing mass moment with respect to origin. That's why I'm taking m1 r1 vector from the origin, m2 r2 vector. Yes. Now they are saying write down the mass moment of m1 vector with respect to m2. So what I will write? So first of all, mass m1 mass into r vector. Now it is the observer, so this vector I will consider. Correct? With respect to m2. Yes. So I will write r3 vector. Done. You understood how to write mass moment? Yes. So what it is? So simple. Just don't remember anything what it is. Just remember mass into position. Yes. Its position is. Write it down first. Oh wait. So it's unit. Unit. Tell me its unit. Sir, mass kg. R position meter. Okay. So can I say kg meter? Yes. Next is its this scalar or vector. The vector quantity. It is a vector quantity. Write it. This is for this is. Okay. Hmm? Then no. Center of mass of particles or center of mass of discrete particles. Array. This is x-axis. This is y-axis. Hmm. Everyone, I will use this it. This is x-axis. This is y-axis. Please see everyone. I am taking this as a m1 particle. Let's say this m2 particle, m3 particle, m4 particle, m5 particle. Let's say 5 particles I am taking it. Hmm? Now I want to calculate their center of mass. So what does it mean by this? Sir, they are the discrete particles. One particle, this 1, 2, 3, 4, 5. I want to calculate the center of mass. It means so that I can remove all the 5 masses and just point out one place. We can where we can consider this whole mass is concentrated. Yes. Let's say I'm saying their center of mass lies in this point. In this point. Yes. Okay. So this is R1 vector. This is R2 vector. R3 vector. R4 vector. R5 vector. Correct or not? And this center of mass, na, I am saying its position vector is like this. So can I write this as position vector of center of mass? It is good, na? Position vector of center of mass. So I am writing formula because see R M1, M2, M3, M4, M5 we know this thing. R1, R2, R3, R4, R5 we all know this thing. We need to calculate this position, means this position, this length or this vector we need to calculate. So how you will calculate? The position of center of mass. What I am writing? Position of center of mass. Yes, in vector form I am writing summation of mass movement by total mass. Summation of mass movement. Yes. Now we are taking origin as a reference. Na? Every time we will use the origin. Okay. So how you write mass movement? Tell me. M1 R1 vector. Yes. So M1 R1 vector plus M2 R2 vector plus M3 R3 vector plus M4 R4 vector plus M5 R5 vector divide by total mass M1 plus M2 plus M3 plus M4 plus M5. This is our position of center of mass formula. This is our full and final formula. Simple thing. If we know M1, M2, M3, M4 masses, we know their position vectors R1, R2, R4. Just put it down. What you will get here, one vector you will get. That vector is the position of the center of mass. Our main motive is to calculate the position. Na? Every time center of mass position we have to calculate. Now tell me one. Now tell me one thing, everyone. Okay, sir. You consider all this. You calculated the position of center of mass. Yes. Now, if someone is asking you, okay, I understood all the. If you remove all the masses, you can assume whole mass is there. It means what is the mass here now at this point? M1 plus M2 plus M3 plus M4 plus M5. Yes or no? Then this we are saying whole mass is concentrated here. So here mass is this, that much. Yes, its position is this. Correct? Write it down fast. Or don't write it down. Wait. Right. Just 1 second. 1 second. I have another good formula also. No, everyone. Sir, position vector. How you write position vector? X I cap plus Y j cap plus Z k cap. Yes. X coordinate, Y coordinate, Z coordinate. Yes. So directly, if I am not interested to find this vector, I want to write directly X coordinate of center of mass, Y coordinate of center of mass. So how I will write? I will write this way. X coordinate of center of mass. Sir, vector, no vector, only coordinate I am calculating. I will write M1 x1, M2 x2, yes, M1 plus M2 plus, correct or not? Now write it down. Na? M1 y1, M2 y2, M1 plus M2, Z coordinate of center of mass, M1 z1 plus M2 z2. Very easy, correct or not? So both the forms that we have, if we want to calculate in vector form, then we will write that green formula. If we want to write direct coordinates, then also we will write that formula, blue one. Okay. Or let's say today we started new chapter. Now from now I am taking this guarantee or anything you will say. Let's say today you have any doubt about any topic. We are doing class in between. Let's say you are not asking. When the class is finished, then ask me, sir. I am not understanding this concept, so please repeat me. I will repeat it. Yes. Guarantee? Yes or no? That much I can take guarantee. Done, done, everyone. Done. Hmm? Example, question means question. If we have 1 gram particle, its position are given as 2, 3, 4 meter. Another we have 2 gram particle 1, minus 1, 2 meter. Another particle is 2 gram, its position is 2, 0, minus 2 meter. Find position of center of mass. Find position of center of mass. Yes, sir. This question is correct. Na? They are not asking find center of mass. Find position of center of mass. They are asking. Yes. Huh. Everyone. When I write the formula after explanation, try to write with me. Yes. Three particles, their masses m1, m2, m3 masses are given. Their coordinate x, y, z coordinate of first mass, x, y, z coordinate of second mass, x, y, z coordinate of third masses. So what is this? Meter. Meter. They are saying simple. They are in the grams. Yes. So we need to convert in kg. I will tell you all the things. Sir, we have two ways. If we calculate center of mass position in vector form, how I will write? m1 r1 vector plus m2 r2 vector plus m3 r3 vector by m1 plus m2 plus m3. Correct or not? Sir, m1. See, these are the vectors r1, r2, r3. If you put here m1 like 1 gram, 2 gram, 3 gram, gram will be, you can take common. Here also gram cancel out. So it doesn't matter if you change in kg or not. Yes, it's your choice. If you are changing in kg, no issue. 10 to the power minus 3, all thing will cancel out eventually. So you can use gram, milligram, whatever they can give you. Yes, because in the denominator also there is a mass. m1, sir, 1 gram. So directly I am writing 1. r1 vector. Sir, this is some coordinate. Yes, if I make it, it will be like this, na? Sir, this is 1 gram. Its coordinate is 2, 3, 4. Can you write this vector if you know the coordinate? Tell me. How you will write? Sir, 2 I cap, 3 j cap, 4 k cap. In work energy power, many times I told you. From here, this is the vector I want to write. So this minus this 0, 0, 0. Final this final vector 2 minus 0. So 2 I cap, 3 minus 0, 3 j cap, 4 minus 0. This, yes, this way you can write vector. So what is the R1 vector? R1 vector is 2 I cap plus 3 j cap plus 4 k cap plus M2. How much M2? M2 is 2. Then R2 vector is I cap minus j cap plus 2 k cap plus M3 is 2 2 I cap 0 j cap. So can I write skip it 0 j cap? Okay, right. J cap minus 2 k cap. Total mass 122 means 5. So 2 I cap, 2 I cap, 4 I cap, and this is also 4 I cap. So how much I can write? 8 I cap. 3 j cap minus 2 j cap means j cap, and here 0. Okay, so that is only j cap. 4 k cap and plus 4 k cap 8 k cap minus 4 k cap means 4 k cap by 5. Is this a vector? Yes, sir, it is a vector. How you can write this in this way, sir? 8 by 5 I cap plus 1 by 5 j cap plus 4 by 5 k cap. Hmm? Try to write with me, na? Because it is easy thing. Easy thing. It means, sir, it means simple. Simple, where is the, wherever, let's say m1, m2, m3, here let's say center of mass is coming. Its coordinate you can say 8 by 5, 1 by 5, 4 by 5. This is also a vector, so vector also you can write this way. 8 by 5, 1 by 5, 4 by 5. How do you know? Are calculate this vector. How you will write? Final minus initial 8 by 5 I cap, 1 by 5 j cap. Yes. I know this thing sometimes people don't know, sir, how to write vector. If you forget this thing, it will be useful in physics everywhere. So write it down in the corner somewhere. Hmm? Another way. By another way, I only find the x coordinates. Y, z you can calculate by your own. Or I am saying or. So let's say I am not interested to find the this in vector form. I want to directly write the x coordinate y and z. Yes. How you will write x coordinate of center of mass? Sir, m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Tell me m1. Sir, 1 gram. X coordinate 2 directly. Okay, 2 plus m2 2 gram. X coordinate 1 plus m3 2 gram. X coordinate 2. Total mass 5 we know. 2 plus 2 4 plus 4 8. So 8 by 5. Hmm? So this is also 8 by 5. See, y coordinate you will calculate 1 by 5. Z 4 by 5. You can calculate this way also. Both the ways are same. Hmm? Okay. Today who is absent? Jenny and Jenny is absent, no? Only Jenny and Tushar. Cookie boy. Arvind. Arvind. Arvind, then he will come late. Okay, after the first class, nearby. Okay. Note point. Write it down. Note point. So today we got to know one new thing. Center of mass. Let's say you have little bit idea, but mass movement you don't know. I think mass movement you don't know. So you got to know one thing. New term is mass movement. So write it down. This thing. Summation of mass movements with respect to center of mass is zero. Summation of mass movement with respect to center of mass is zero. Always. Center of mass is zero. Everyone please see. M1, let's say M2, let's say M3. Their center of mass and their position vectors is given like this. R1 given, R2 vector is given, R3 is also given. Correct? Its center of mass, let's say here I am saying center of mass is here. This. Correct or not? Hmm? This is the position of center of mass. What is the point I gave you? With respect to center of mass, yes? If directly I will ask you, tell me the summation of mass movement. What you will say? Sir, m1 r1 plus m2 r2 plus m3 r3. This is the summation of mass movement, na? With respect to origin. Origin. Yes or no? With respect to origin. Now this line, in this line, I am saying summation of mass of this mass movement with respect to center of mass. Means now, sir, let's say center of mass is here. With respect to it, let's say I am saying this is RCOM. Hmm? Means, sir, you are saying this thing with respect to m1, mass moment of m1 with respect to center of mass. So can I say, let's say this is r3 vector, or r3 is I have taken, na? Let's say r4. Huh? So this position I am taking, let's say r5 vector, and this position, let's say I am taking r6 vector. Hmm? Now see, now I am writing summation of mass moment with respect to center of mass. First this one, sir, m1 r4 vector, correct? Tell me, m2 m2 r6 vector plus m3 r5 vector. This is the summation of mass moment with respect to center of mass. Correct or not? This, and I am saying this is zero. How do you know, sir? See, you know this much, na? Addition of triangle. Sir, A vector is this. If B vector is this, then C is this. So what is C? C is, sir, A vector plus B vector. You know addition or not? Hmm? See this triangle. A vector plus B vector is equals to C. Yes or no? So can I write R1 vector is equals to R4 vector plus R center of mass. Correct or not? Hmm? Yes or no? See this triangle. This, this and this. So can I say R3 vector is equals to this vector plus this vector, RCOM plus R5 vector. Now see this triangle. This plus this is equals to this. So R2 vector is equals to R6 vector plus RCOM. Hmm? Correct or not? Tell me up to here you understood? Simple. Tell me. M1, R4. Tell me the value of R4 vector. So can I write R1 vector minus RCOM? Sir, why you are writing? Because we don't know R4, R5, R6. We don't know R4, R5, R6. We only know R1, R2, R3, R center of mass. This is given. Yes, so I am writing in their terms. Plus M2. Now tell me R6. Sir, R6 is this. R2 minus RCOM. Correct or not? Plus hmm, R5 na? R5 is R3 minus R3 minus RCM, correct? Sir, M1 R1 vector plus M2 R2 vector plus M3 R3 vector, correct? Hmm, correct or not correct? Sir, M1 RCOM, M2 RCOM, M3 RCOM, yes. So what I am doing na? Now I am taking RCOM common and I am writing M1 plus M2 plus M3. अरे रे रे रे. Tell me, correct or not up to here? Hmm? Okay, sir. Now see. Take it like this minus. You know position of center of mass. Can you calculate? Sir, we have the formula na position of center of mass. Directly I am writing. Tell me. Sir, M1 R1 vector plus M2 R2 plus M3 by total mass. Correct or not? Multiply by M1 plus M2 plus M3. So ding ding. This whole is in minus. Yes or no? This will cancel out. So this and this whole cancel out. So null vector. What is this? The nulla vector. Nulla. Hmm. I did this proof, so only you will little bit revise this vectors and all. Yes or no? Otherwise, there is no use that much. But okay, it is good. At least whatever you are writing in the notes, you have that idea. Na? Tomorrow we have one more class. Done. Hmm? Correct. So can you solve any question this type? They will give you masses, their positions. Yes. Correct or not? You can solve it. Now see. General thing we done. Now we are seeing this center of mass of 2 point mass. 2 point masses. Hmm? You haven't written? Write it first. This clock is correct. Hmm? Yes, correct. Huh? Yes. Done, na, done. Huh? Done. Center of mass of 2 point masses. Sir, very easy. Everyone, please see. This is point mass m1. This is point mass m2. What it is? M2, sir. Correct. And it is given their separation is d. Now I am asking where is the center of mass? Sir, very easy, sir, very easy. Now nothing I am giving. I am not giving the coordinate of this coordinate. Yes. Derivation you want or direct formula you want? Formula, हाँ. तभी तो तुम्हें नहीं आता समझ फिर से derivation I will do with the derivation. Yes. Formula you have to remember, but just see the derivation. Let's say we have learned that much thing. Is it any useful or not? Simple. Sir, whenever they will ask, na, do this thing. Let's say this is y axis. This is our x axis. Simple, yes. Means now this m1 is at origin. So can I say its coordinate is 0, comma 0? Very easy. So its coordinate d, comma 0. So from the center, this is d length. Huh? So can I say d, comma 0 its coordinate? Very easy. Now can you calculate center of mass? Yes, sir. X coordinate of center of mass is, tell me. Sir, m1, x1 is 0 plus m2, x2 is 2. Total mass m1 plus m2. m2 d by m1 plus m2. Hmm. Everyone, correct or not? Y coordinate of center of mass. So don't find out. It will come out 0. Why? If both the mass is on the x-axis, so their mass, their center of mass must lie in this line. Na? If it is lying, center of mass is lying in this line, so how its y coordinate will come? Let's say center of mass is coming here. So its coordinate will be x1, comma 0. Y coordinate will become out 0. Let's say you are not believing, you don't believe me. Na? No, no, you don't believe. Sir, m1, y1 is 0 plus m2, y2 is 0 by m1 plus m2. Now tell me, you believe me or not? Yes. Okay. So I am saying that its center of mass, let's say here, it is coming. Now see, what you have to remember. Direct formula I am saying. If two masses are given, then you won't do the x-axis, y-axis. Just this we have done the proof. Center of mass, this. Yes, it's x, this. What is this? X coordinate of center of mass. This is the origin and this is the coordinate. This coordinate is m2d by m1 plus m2, comma 0. This is the coordinate. So can I say this length is that. This coordinate is representing this length. Yes. So remember this thing, everyone. If two masses m1, m2 is given, their separation d is given. So if someone is asking you, please see na, this you have to remember. If someone is asking you, sir, find its center of mass position, or means at what distance it is lying. So you will say, let's say from here you want to write the position. Sir, from that much distance, I am saying center of mass this, that much distance you want to write. This distance you will write this way. From m1 you are writing this distance, so you will write m2 into separation d by total mass m1 plus m2. Yes. Let's say, sir, I want to write from this way. This distance I want to write this distance. How I will write this? Very easy. From m2 you are writing distance, so you will go to the opposite one, m1. m1 total distance by m1 plus m2. If you are not believing me, add both of them. You will get d. Correct? Seriously. The d will be common. m1, m2 both will cancel out. D will come out. Correct? So you have to remember from this point at what distance center of mass is lying. So you will write from this point, na, sir. Another point is m2 into separation by m1 plus m2. So from this point, how much distance the center of mass is lying? m1 into d by m1 plus m2. So tell me. Hmm? Can you remember this much? One more point. Only remember this point. Another point is this. Let's say I am saying this is a x1. Hmm? This list distance is a x1. This is a x2. What I am saying? This is a x1. This is a x2. So remember m1, and this is the center of mass. Remember m1 x1 is equals to m2 x2. Always try to remember this. Hmm? So how do you know? So this x1 na x1 is this. If you put this in here, so you will get equate both of them. You will get same answer both the sides. Yes. If center of mass is at a distance x1 from m1 and x2 from m2, so m1 x1 is equals to m2 x2. Remember it. Remember it. Don't worry. Remember. Write it down fast. 2 minutes, na max. Not 2 minutes. 1.5 minutes. Uh, hello. 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 Done. Don't do this. स्केल वाला मत लाया कर सच में। ओ, क्या कर रही है? अब हथियार लेके आ रही है, दूसरों को फंसा दे रही है। Question is, next question is, m1 is displaced by distance x1. m1 is displaced by distance x1. Find displacement of m2. Find displacement of m2 such that find displacement of m2 such that center of mass remains at same point. Such that center of mass remains at same point. m1 mass this, m2 mass this. Let's say I'm saying this is the center of mass. This separation, please everyone, this separation is given as A. This separation is given as B. In the question, what is given, sir? M1, M2, A, B. That much things are given. Now, question is this. I am saying I am taking this M1 and displacing it here. What I am taking? No, not taking here. What I am saying, I am taking this M1 and displacing it here. How much displacement? X1. It is given, na? So now this is the final position of M1. Hmm? Or can I make it here? Let's say you want to see my technical power. Huh? Where is copy paste? Copy, copy, copy. Where is the paste? Not happening. So today I can show you my power, na? Come, come. Where is copy? अरे यार, leave it, leave it. Another day I will show you, na? Today I will. Hmm. Question is, see, I am saying m1 m2 masses are there at a separation a from the center of mass, at a separation b from the center of mass. Question is saying I displace this m1 mass at a distance x1. How much distance? X1. This is m1 mass. Now I am saying this thing. I displace this as a distance x1. Tell me how much I have to displace m2 mass so this center of mass remains at its own position, at their original position. What do you think? If two masses are there, if I am displacing m1, so center of mass also try to shift this way. Correct or not? Yes or no? Simple thing is this. Yes. Now I displace this much. So center of mass must have to displace. But that's why they are asking center of mass is at the same position. So tell me how much I have to displace this m2 mass. Same amount to here. Okay. So displace this as a separation x2, let's say. It depends now whose mass is greater, whose mass is. If both are same mass, then I will say something about it. Both separations are same, then I will say something. So I'm saying let's say x2 distance I displaced it. This is b. It is given. Then center of mass remains same. Yes, I am applying same thing. What thing, sir? Sir, here can you write m1a is equals to m2b. m1 into a equals to m2 into b. In the last question I told you. So here let's say this is the final diagram. So can I write m1 into x1 plus a, m1 into x1 plus a is equals to m2 into x2 plus b. What is this? m1 x1 plus m1 a is equals to m2 x2 plus m2 b. Ding ding. Both are same. Yes or no? Both are same, so it will cancel out. So we need to calculate x2, x2. So equation is this, sir. m2 x2 and x2 will be m1 x1 by m2. This is our answer. Hmm. So sir, this question is important. This is also derivation. You have to remember this thing. You have to remember this thing like this. If they are saying they are displacing m1 mass, m2 mass, center of mass remains fixed. So you will say m1 x1, how much you displace is equals to m2 x2. Yes, every way possible. Everyone please see na, last time I am explaining this thing. In this diagram, what you can say? Center of mass here. Arey bhai, center of mass here. So you will say m1 into that much distance. Yes, is equals to m2 into that much distance. Correct or not? Or in another words, another equation you can write how much you displace this m1 mass. m1 into x1. m1 into x1. So same you will write this way m2 and displace this with x2. So you can directly calculate x2 is equals to this. Huh? Can you remember this thing also? Remember this and this both are little bit different. Yeah, yes or no? Write it down. You have to remember this thing. m1 x1 equals to m2 x2. Done? Hmm? Only apply this equation m1 x1 in this whatever way you are remembering. If you are displacing x1, that x2 will be related like this. If center of mass is fixed, if in the question it is saying center of mass initially here, now it is displaced, it is not in the actual position, then don't write m1 x1 equals to m2 x2. That then you can write this m1 and where let's say here center of mass this distance, m2 this distance. Yes, but you can't write m1 x1 equals to m2 x2. When center of mass remains fixed, so you will say this way m1 x1 equals to m2 x2. Correct or not? Okay. Next is center of mass of continuous body. Center of mass of continuous body. Continuous body means two types of center of mass position we will see. First, we have seen the formula of discrete particles. So point masses are there. So how to calculate their center of masses? Now we will see if there is a large body, bigger object. So how to calculate its center of mass? Same formula is like this. So what is the formula? Position of center of mass, summation of mass moment by total mass. Correct or not? This was the formula, na? Summation of mass moment by total mass. Let's say this is any body, continuous body. What it is? Continuous body. It is a continuous body. Yes. Now see what I will do. Everyone please see. First I am telling you how to write the mass moment in continuous body, how to write the mass moment. Because if discrete particles are there, you will write m1 r1. Yes. m2 r2. Here how to write. So let's say take a very small mass. Na? Let's say this mass is dm. Hmm? What is the position vector? So this is its position vector. Let's say r vector. Hmm? Correct or not, everyone? So now I am writing mass moment of this small mass. Sir, mass into position vector r vector. What is this? This is mass moment. Correct or not? There in discrete particles I have written m into r vector. Correct? Hmm? Now I want to write the this thing. So this is a whole body. Tell me where center of mass lies. I don't know. Let's say I am saying here is the center of mass. Just I am taking any position. This is the center of mass. Okay, then tell me its position. Position of center of mass. Hmm? So I am writing this. Position of center of mass vector is summation of mass moment. Everyone, I will take a small dm all the masses. Yes, they are vectors, and I will add all of them. Addition means integration. You know this thing, na? You can say this summation, integration, both are same thing. Yes. So I will say integration, addition of mass moment. This is mass moment, and this is integration. So I am writing integration dm r vector. You are getting what is this summation of mass moment? Correct. By total mass. So dm. This is a very small mass. Integrate this. Dm will be give you total mass. Correct. So this is the formula in integration. Correct. Same formula. If you remember this mass moment integration by total mass. So there you give us that formula also in x coordinate of center of mass, y coordinate. Here how you will write very easy. X coordinate of center of mass. Tell me integration dm. Instead of vector I will write x coordinate of the dm mass. Integration dm. Y coordinate of center of mass. Write it down now. Integration dm y. Oh wait. Don't write it down. I will give you time. You have written this? Not? Okay, then wait. Just one example I am giving you. Then after this, you have to remember all the things. Yes, in the book, you have to remember the center of mass of all the continuous bodies. Uh, this rod, its mass is m, length is L. Yes, this is mass m, length is L. I want to calculate its center of mass. Yes, so how you will do it? Hmm. Everyone, please see. Same thing I will do. Sir, I will go. Let's say I am saying this is placed in the x axis, this is y axis. Yes. So I am saying I am going x distance. Yes. And I am cutting one very small mass, this. its length is dx. How much its length is? Dx. Yes. Its mass will be dm. Hmm? Correct or not? Correct. That this coordinate is 0 comma 0. We know this length is this up to here. Its length is L. Hmm? Sir, I am going x distance dx element I have taken. Can you write this only that element, its mass moment? Can you write? Very easy, sir. Its mass, small mass into its position. X coordinate I am writing. And remember, y, z coordinate I won't write. If it is placed in the x axis, its whole mass, this center of mass comes on the x axis. So only I will write x coordinate. Yes, is no issue. The x coordinate of center of mass is a small mass, yes, and its position x. I told you, correct or not? Integrate this by total mass dm. Correct or not? You will get it everything. Now, first of all, I need to change this dm so that I can integrate with respect to it. How I will write this dm? See, sir, in L length, m mass is distributed. In L length, m mass is distributed. In dx length, how much mass will be distributed? M dx by L. Dx into m divided by L. Unitary method. Sir, in 20 meters, 5 kg is distributed. So in 1 meter, how much? 1 into this by divide. Unitary method. Eh? So can I say what is this, sir? Tell me. dm mass, not length. I am saying in that much dx length, that much mass is distributed. So that this is dm mass. So put it this integration dm is m by l dx. So I am writing this x and now I am writing dx. Integration. What you can write this integration dm? Tell me. So simple m, small dm mass. Their total mass will be m is given in the question. Okay. So from where to where you are integrating? 0 to L. What does it mean by this? Means, sir, in x distance I am going, this moment of inertia I calculated. So total, oh sorry, mass moment I calculated. Yes or no? Mass moment, not moment of inertia. So x distance I am going, this moment of inertia I calculated. So if I am cutting a small particle here, here, sir, one here, one next here, next here, next here. So if I put x0 to xl, all these small particles I will cover. Yes or no? So I am putting limit x0 to L. So sir, this m by L is common or constant. It is integration x dx. This m is there, 0 to L. M cancel out, 1 by L. X integration is x square by 2. 2 I am taking out, 0 to L. 1 by 2L, L square. How much? L by 2. Array sir. What you are saying, sir? If it is a L rod, so its center of mass will be at center. Okay, I know you know this thing. Its center of mass will be at the center. But you understood this derivation or not? Hmm? Now write it down now from this.